All right, let's look at a problem like this, which there are different variations of this problem. Pretty much gives you a bunch of vectors in 3D space and wants you to write them in Cartesian notation, find the resultant force, anything like that. So let's just start with any of them we want. I like to start with the easiest one, which in this case would be vector f. When I look at vector f, it gives me the angle of the vector with x-axis, which I know is called alpha, the angle of the vector with y-axis, which I know indicated by beta, and then it gives me the angle with z-axis, which I usually noted with gamma. Alpha, beta, and gamma are called coordinate direction angles. I have a lecture on this, and I show how these could be used and how the components of a vector could be found using alpha, beta, and gamma. The relation, there's a relation exists between them. Cosine square of alpha plus cosine beta square root of beta plus cosine square root of gamma should result in 1. So even if it gave us only alpha and beta, we can find gamma and go on. So if two of them are known, we can find them. In order to write the vector in Cartesian form, we use something like this: cosine alpha I, cosine beta j, f cosine gamma k. Again, I have a lecture on this. Please watch that lecture if you want to know how and why this is the way we use Cartesian vector. Again, this is a scalar, this is magnitude, this portion is a vector, this whole thing is a vector. All right, so let's write vector f. We're looking at f is 3 kilonewtons. Cosine alpha is 45 I, 3 kilonewtons cosine beta, which is 60, and that's j, plus 3 kilonewtons cosine gamma, and which is 60, sorry, and that is k. Another way of writing it, you could just write the 3 kilonewtons out and say cosine 45i, cosine 60j, cosine 60k. All right, this is our vector f. We'll get back to this later. Let's look at p. P is two angles given. They're not coordinate direction angles. It's not with x-axis. We have an angle with x-axis, but it's not with the vector and x-axis. We don't have an angle from the vector and y-axis. We have an angle from vector and between vector and z-axis again, but we don't have the angle of the vector and all three axes. So that therefore we don't have alpha, beta, and gamma. What we have here though is called azimuth and transverse angles. Means we have the angle with one of the axes right here, and then the shadow of this vector or projection of this vector on xy plane, we have the angle of that. Okay, so this vector makes an angle of 30 degrees with xy plane. Okay, right here. Oh, never mind, I'm sorry. 40, because it makes angle 50 with y-axis. So two things we can find right away here. Go parallel to xy. This will be z component. So PZ would be 2 kilonewtons, and it's adjacent to cosine at 250, so it's cosine 50. So we have one of the components. So if I want to write angle, the full vector P, something I, something J, something K, that K is already 2 kilonewtons cosine 50. I already found that. Next thing I can find is this dotted line right here. Okay, which is right here. This is that dotted line right there. Okay, it's adjacent to the 40, so this dotted line length is 2 kilonewton cosine 40. Or some people might like write it as sine 50, which is fine. Okay, so I know this line right here, and it's flat on XY plane. It's kind of like this, Y, X, and I know this is 2 kilonewton cosine 50. Now this vector, I'm going to use green. This will be Fx, and this will be Fy. If I find these two, I can find my I and J components right here. I'll go with Fy. I'll go with Fx. It's easier. It's adjacent to 30. So whatever this is, whatever is in this oval border, cosine 30 will give me my Fx. So 2, exact same thing I'm going to write here. 2 kilonewtons cosine 50. This whole thing, cosine of 30 will give me my Fx. Cosine 30. And then next thing I want to do is this whole thing, this line right here, whole thing, sine of 30 will give me my Fy. So 2 kilonewtons cosine 50. This whole thing multiplied by sine of 30 will give me my Fy. So there you have the three components. I kept it like this on purpose so you can kind of figure out, oh, this is cosine, this is sine, and so on. All right, let's look at the last one. Quick reminder, in 2D vectors, when we had, for example, if this was 4 kilonewtons, a 2D vector, and we had what is known as a slope triangle. Okay, so for X and Y, for Fx, you would go 4 kilonewtons and then 4/5. For Fy component, you would go 4 kilonewtons and then 3/5. We'll do the same thing here for vector Q. The difference is this 5 here was 3 squared plus 4 squared. That was 5. In this one, we have 3. We have 3 sides. Right? We have a 2, 2, and a 1. And we are trying to find this right here. This is 2 squared plus 2 squared plus 1 squared. So these are kind of like slope triangle, but just in 3D. Again, follows the same kind of procedure as 2D. So if I want to write Q in vector form, I have 4 kilonewtons. I'm looking for X component, so I go with the X length, which is 2/3. And then let me see, it's also kind of pointing away. This will be fx. It's pointing away from my positive x and towards negative x, so that will be negative. Okay. J component, I go with parallel, whatever is parallel to y. So this length is important to me, which is 2. So that's 4 kilonewtons, 2, and then again I use this 3. And this one, the y component is right here, and it's pointing towards positive y, so that's going to stay positive. And then lastly, for z, I go 4 kilonewtons, and I take the z, should write a different color, z, that will be 1 over 3, and it's kind of pointing down, and it's towards positive z, so that's going to be my positive. Sorry, the colors got mixed up a little bit. All right, so I'm going to write it clean here. So it's going to be minus 4 2 over 3 I plus 4 2 over 3 j 4 kilonewton 1 over 3 k. All right, I think I have all three vectors. All I have to do is add them together to find the resultant force. My F was 3 cosine 45 I. Do I have the math on these? Yes, I do. So let me just write the numbers that I have for these. F is 2.12 I, 1.5 J, 1.5 K, and the unit is kilonewtons. My vector P is going to be minus 1.33 I, 0.766 J, 1.29 K, units of kilonewtons. And then Q, once you do the math, is going to be minus 267 I, 267 J, 1.33 K, units of kilonewtons. Again, I write it this way so it's much easier. Just add all of these together, and that will be minus 1.88 I. Add these three together, and that will be my J, 494 J, and then add these three together, and that will be my K. I hope this was helpful. Thank you very much.